Hi, my name is Nick Watson. I'm an INLS 625 with Professor Raja, and this is my project that I did on NFL statistical analysis. And I, going into this project, was interested to see if I can find any correlations with any given NFL attribute and see if there was any advantages to, let's say, like a passing team compared to a rushing team. I also wanted to add the given attributes of defensive statistics to see if there's any correlation between the two. So going into this project, my thought process was there's so many people that can utilize this kind of information, and it's not readily available. So people who play like fantasy football, or people who gamble on sporting events, and even the players and teams themselves could all greatly benefit from having a greater understanding of the data and how it's applicable to whoever needs it. So I wanted to get as much data as possible from as many sources as possible and had intentions of building a model that could help someone who was interested in this. And it was kind of complicated in a sense of I had to bring in several different data sets because I couldn't find any one good data set that had everything I was looking for. And there's really not a lot out there if you do your own independent study on this that have full data sets. I looked on Kaggle to see if they had a good data set, and their data sets that they had there were almost too in-depth and not with the things I was looking for. The only things they have there is like specific player play-by-play action, which is not what I needed. So, if you're trying to do a project like this on your own, just keep that in mind that the data is really limited. So with that in mind, what I did was I gathered a few data sets, and to do so, I had to go to a few different sites. Where I pulled most of my data was from NFL.com, ESPN.com, and there's a couple other ones that I was able to pull all these different attributes in to one data set. And a lot of the statistics that I was looking for, as you can see here, were offensive statistics and defensive statistics. And more specifically, I wanted to get the points per game, the passing yards per game, rushing yards, the total yards for the season, total points, and the points per game. So I try to get every variable I can think of that would contribute to building a decent correlation model. To do so, I also added the defensive statistics, pretty much the same stats, just on the other side of the ball. How many points per game were allowed, how many passing yards were allowed, and so on. And then I also, so I can make this a supervised set, I decided to add a target attribute of whether or not the teams made the playoffs and whether or not they made any division appearances and if they actually won or lost those appearances. So I kind of worked with two different sets and two different models, and I just wanted to see if I can just find any correlation that could help me better understand this data. So in talking about the different data sets, there was a lot of preparation involved. I had to pull all the data from the different sites, and then once I had all that data, I had to clean it and trim it up some, so it was able to build a better model. And in doing so, I predominantly use Weka, which is just something I'm the most familiar with at this point. And I ran a search method on the attributes to get a ranking. When I originally started, I probably had 20, 25 attributes, and a lot of them were redundant. And what I mean by that is you can see here in the ranked attributes, everything is per game. So when you're talking about the points, it's the points per game. Well, in the data set that I had, it also had the total points for the season and the total yards for the season, and the ranker just showed it as being redundant. So I essentially just X'd all the for season stats and just kept it to a per game level. That proved to be better for the the graphs and the tree models and stuff like that, since instead of, for the full season, it's really not going to benefit you that much as knowing, what your per game statistics are. In doing so, with this specific model, I did have a lot of overfitting that served a good purpose in a sense of it improved my correct classification, but it also, when you have overfitting, it also complicates your model. Instead of having just a one or two or just a handful of branches, you end up having several, and it can complicate it a lot more. So it's kind of a trade-off. You can go the overfitting route, which is what I ended up doing, and you can also go the generalization route, which is going to simplify it tremendously, but it is going to lower your correct classification percentage. So that is something to keep in mind. In building this model, I kind of wanted to run a few different models to see if one was correctly classifying over the other. I did ones that I'm familiar with at the moment. I did a tree diagram, which proved to be the most successful. I also ran another classification, and I also ran an unsupervised set with a k-means cluster model. And then to get more data, I added the method of bootstrapping. If you're unfamiliar with that, essentially it just duplicates a lot of your statistics and can give you a larger data set. The problem with bootstrapping is it is very biased to the data that you have and what you're trying to achieve, so it can skew your results in a sense, and you can't really rely on bootstrapping as a good method of proving any correlation. It just essentially helped me just build a bigger model to test against. So the tree diagram, which is the first classification I ran, as I mentioned a minute ago, there was a lot of overfitting, and you can see in the picture to the right, it is a complicated model. If you were to go through each branch of it, it starts with the points per game, and then it has a threshold of 24 points per game. When I did the generalization model, this is all it included. It was just the points per game threshold, which I did test against the last few years of NFL statistics, and it was about a 65% correct classification. So it's not a horrible model by any means, but it's just not enough to say, hey, this is good data here. So I needed to go the overfitting route, and if you look through this, you can see it is rather complicated, but it did get a 25% increase correct classification, which was very important. And as you can see, the points per game was the highest contributing factor, and that's taken into consideration everything else that's included with that, with your rushing yards, your passing yards, your points allowed, and all that. It still found that just the points per game were the highest contributing factor, which with anyone looking at this data, that is, it's not groundbreaking by any means. We all know more points, you have a better chance at winning. So wasn't too happy with the results with that. I also did run this other classification, which did give me a rather high classification percentage, but keep in mind this was with bootstrap data, so you have to take it for what it is. This is nothing you can carry on as sufficient evidence enough to say this is a good model, but it was more accurate than the tree classification to a point. The prune version, at least. If you go the overfeeding route, that still beat out the Naïve Bayes classification. So I also decided to run an unsupervised set and eliminate the variable to a point of whether or not the teams would win the playoffs or win their division. So what I wanted to do was run some clustering models to see specifically more of the correlation between the points per game compared to how much you passed in that game, and then also the points per game compared to how much you rushed. Essentially wanted to see if there was an advantage for passing or rushing, because there's always been a debate over one being better than the other. So if you just look at the scatter plots on the right, you can see with the points per game and the passing yards per game, it's more linear. You can see it progressively increases. The more passing yards, the more points. Whereas if you look at the rushing yards per game, it's all scrambled. So that does tell you that you have an increased chance of scoring if you pass more, but it doesn't disregard rushing altogether. So it really is not as cut and dry as I was hoping. I was really hoping to see that there was a clear, I guess, better opportunity at winning if you pass more or if you rush more, but it just didn't. The data didn't show me that. And there's a lot of reasons why this model didn't give me the results I was looking for. When you consider football or really any outdoor sport for that matter, there's a lot of variables that play into how a team's going to perform. You have the weather, if it's snowing out, which, football, plays during snow and all that type of weather, there's obviously going to be, complications to a team performing how they normally do. So they're probably going to rush more because they're not, it's not as easy to pass. So essentially, just the weather alone really skews the results. On top of that, you have to take into consideration injured players. Teams. There are certain teams that just historically have played very well against other teams, and vice versa. So there's too many variables and not enough data on those variables to where I was able to build a decent model that I was happy with. So that's just something to take into consideration. Now, if I was to just evaluate the project in whole, I'm glad I was able to do it. It gave me a lot of hands-on experience with different software systems. I worked with SAS, Weka, a little with Orange, and I just wanted to get different looks at how I can analyze the data I had. If I had to do anything differently, I would go into it understanding that I needed a lot more data, a lot more attributes than just offensive and defensive statistics. There's a lot of outside variables that actually play a very big role in how well a team is going to do. So overall, I'm happy with the experience, but disappointed with the results. I did see at least that there was a better chance at scoring more for teams that passed more. And if you observe the league over the last few years, the team has gone to more of a passing style, which, there's several reasons for that, but, it does work, and, teams are, seeming to rush a lot less lately. So it's nothing groundbreaking. That's kind of already known stuff. So, that is the disappointment and the downfall of this model. But it was good experience. If you have any questions or you have any ideas on things I can maybe add, to tweak this project, I'm interested in hearing that from you. And I appreciate you watching the video. Thank you.